students, and welcome back to Study Room. So as I told you in the last video, we are going to continue with the non-conventional sources of energy and we're going to do the part 2 of it. Okay, let's begin. Okay, so the first one that we're going to do in part 2 is geothermal energy. So before I show it to you what it actually means, can you just look at the word and think what it might mean? Geo and thermal. You've all studied geography. It also has geo. What does geo mean? Geo basically means anything to do with the earth. And what does thermal mean? Thermal obviously means anything to do with heat, right? Thermal energy using in the thermal power plants, using the coal or using water or using solar panels in the solar thermal plants, right? So thermal obviously means heat. So what does geothermal mean? The earth's heat, right? So even before we have seen the definition of it, we already have an idea about what we're going to study. So you should always do this before you actually read the thing. You can start thinking about it to just get your brain all active, Okay, now let's see what actually geothermal energy is. So it says that molten rocks formed in the deeper hot regions of Earth's crust are pushed upwards and trapped in certain regions called hotspots. Okay, when underground water comes in contact with the hotspot, steam is generated. Hot water from the hotspot region finds outlets known as hot springs at the surface. Okay, so what is the process basically happening? Deep inside the surface of the earth, there is molten rocks or what comes out in the form of lava from the volcano, right? So we know that the core of the earth, as we go deeper and deeper and deeper towards the center of the earth, so the center sphere. So as we go deeper and deeper and deeper towards the center of the earth, we know that the earth is a sphere, right? So obviously, if this is the earth, it has some center which is known as the core, right? So this is the hottest region of the earth. So, and even if not as deep as the core of the earth, but as we go deeper from the outermost surface of the earth or the crust of the earth, we go deeper, there is some hot molten rocks. These rocks are not in solid form, these are in a molten form. So what happens in these deeper hot regions, sometimes because of some physical phenomenon, these molten rocks are pushed a little upwards towards the surface of the earth. Okay, and these places, so this is the surface of the earth. So this is the earth's surface, and somewhere here deep are the molten rocks. So sometimes due to some phenomenon, these molten rocks are pushed upwards somewhere around here, closer to the surface of the earth or the crust of the earth. These places are known as hotspots. They are trapped there. So it says that they are pushed upwards and trapped in certain regions known as the hotspots. Then we know that there is an underwater table. You know the water table, you studied about the water table, you studied about water table depletion. So we know that somewhere below the surface of the earth there is water, right? There is water stored underwater, underground, under the surface of the earth. So sometimes this hotspot is very close to this water table or the underground water. And what happens when water comes in contact with something very hot? What happens when we heat water or we boil water? It turns into steam, right? So if this water, underground water, comes in contact with these absolutely hot molten rocks, what will happen? That water will turn into steam. That is what the next point says, that this underground water comes in contact with the hotspot or the molten rock in the hotspot and steam is generated. Obviously the water evaporates and forms steam. Then you know that steam has a much higher energy, right, than water, because it has been evaporated to that form. So it has a much higher energy, so it can't just stay trapped inside the surface of the earth. It has to find some kind of an outlet. So when this generated steam finds an outlet, you must have heard of hot springs in different places of the world. People go there to relax. It's like a natural sauna, right? So that is what gives rise to hot springs. So that hot water from the hot spot region finds outlets. Not hot water, actually hot steam and hot water. They find these outlets in the hot spot regions that give rise to the hot springs near the surface, or these hot springs come out of the surface. Okay, so this hot water, steam that comes out from the surface, because it has so much energy trapped in it, this energy can actually be converted to, again, electricity. Okay. So how will that take place? Again, it could be the same process. It could be rotating the turbine and then generating electricity. The same thing that we have been doing for so long. Okay. Now, nuclear energy. What is nuclear? What is nucleus? You know what the nucleus is? If this is the atom, right? If this whole big sphere is the atom, there is this one small tiny region inside the atom, in the center of the atom, which has all of the mass of the atom, which is known as the nucleus, right? I hope all of you have studied about this, right? So this nucleus can undergo two processes, that is fission and fusion, right? So if you can't remember the meaning of the word fission, you know what the meaning of the word fusion is, right? You must have heard fusion dance, fusion cuisine, fusion food. So fusion basically means fusing the, if it's fusion dance, it's sometimes fusing classical and western dance. If it's fusion food, it's sometimes fusing, say, your typical Indian food with some western food. So fusion always means combining, right? So if you can remember what fusion means, obviously fission is the opposite of fusion. So if fusion is the combining of two particles, fission is basically the breaking up of one particles into two or more. So what is nuclear fission? From that definition, nuclear fission is the breaking up of a heavy nucleus into several daughter nuclei, right? So let's read in your PPT. So here it says, the nucleus of a heavy atom such as uranium, plutonium and thorium, these are very heavy atoms. When this nucleus is bombarded, what does bombarded mean? When it is in one way attacked. Like bombarded means you kind of like, what is it? Bombarded with low energy neutrons. So it's kind of like they're like continuously at very high speed thrown at it. That is what bombarded means. So when this nucleus of a heavy atom, say uranium, plutonium, thorium, is bombarded with low energy neutrons, that nucleus basically splits, or that nucleus breaks up into smaller, lighter nuclei. Obviously, one heavy nucleus, when it breaks, it would give smaller, lighter nuclei. This process is known as the fission or nuclear fission. Okay. So look, here it's given target nucleus. What does target nucleus mean? That the nucleus which is actually our subject of treatment, or which is undergoing the fission process, right? So what happens? This neutron strikes many neutrons strikes this nucleus, and what happens? It basically breaks up into two or even more fission products. Fission products means the product that we get after fission. So this target nuclei, this heavy nucleus of, say, uranium, has undergone fission, so it gives 2 or say 3 fission products after undergoing the process. Okay, great. Now, nuclear energy. Now you must say, okay, this phenomenon takes place, like you bombard the nucleus with neutrons and then it splits into lighter nuclei. What happens? How do we get energy or electricity? This is how. Fission releases tremendous amounts of energy. Because, why is that? Because the nucleus is one very heavy, very strongly held together particle, right? So when you have to break apart any strong or held together particle, you're going to need energy. So when it breaks apart, it is going to release that energy, right? That is why a huge amount of energy is released when a nucleus undergoes fission. So it says that a fission releases tremendous amounts of energy if the mass, this is the condition. This is the condition for fission. Okay, the condition for release of great amounts of energy. If the mass of the original nucleus is just a little more than the sum of masses of individual products. What does that mean? If this is my original nucleus, right? Nucleus. This is my nucleus, target nucleus. After fission, after it is bombarded by neutrons, it breaks up into 2 nuclei. Okay. So say this has the mass capital M and this has the mass small m1 and small m2. So what does it say? that large amount of energy, I'm using AMT for amount, large amount of energy is released if, what does it say here? Original nucleus is just a little more, mass of the original nucleus just a little more than the sum of the masses of the individual products. What does that mean? Mass of the original nucleus is m. If this m is more than or greater than this sum of the masses of the individual products, that means m1 plus m2. So if this m is greater than m1 and m2 even by a little amount, then a huge amount of energy is released. Okay. Nuclear fuel is part of a self-sustaining fission chain reaction that releases energy at a controlled rate. That means nuclear fuel, what happens when nuclear fuel is generated? This fission process, it doesn't just go out once. It keeps on going. It's a chain of events that keep happening, and thus a lot of energy is released at a controlled rate. Okay. So this nuclear fuel actually takes place inside a nuclear reactor. So what is a nuclear reactor? It is basically this big machine or this big setup in which this fission process, this nuclear fission process is done at a controlled rate, because the nuclear energy released is around 10 million times more than the energy released by your carbon or the coal. So you can just imagine it is like many times the amount of energy, and sometimes if it is not done in a controlled way, it can actually be very hazardous. So if it could be like a bomb blast. So bombs use this process of nuclear fission. Okay. Well, a bomb uses both fission and fusion reactions, but what I'm trying to say is fission reaction releases a huge amount of energy, which if it is not done at a controlled rate can actually lead to people actually dying. It could lead to loss of lives. It can be very dangerous. That is why it says in a controlled rate. So it is actually done and that is why it says under at a controlled rate. So it is actually done under a lot of care and supervision only it takes place. Okay. And at a lot of places nuclear energy generation is banned because it is that dangerous. And why? Other reasons that it is not allowed, we're going to study what are the cons of generating nuclear energy. Okay. But right now, so now we're going to see a video which will give you a little more idea and a little more information about nuclear energy and its generation. Okay. Okay, so keep reading the facts given below with me. Okay, let's go. So it says that nuclear energy is the energy of the nucleus or of the core of an atom. Right? We know what the nucleus is. Now, atoms are tiny units that make up all matters in the universe. You've been studying this for far too long, so you have a very good idea about what this means. Then it says energy holds the dense nucleus together and it contains a huge amount of power. So that's what I told you. Why is so much energy released? Because the nucleus is a very tightly held structure. So as it says in this video also, that the energy holds the dense nucleus together and it actually has a lot of power and energy that is holding it together. Then it says that nuclear energy can be used to create electricity. Again, follow that yellow strips, and it must be first released from the atom. Obviously, the two kind of atomic reactions create nuclear energy. So we have right now we have studied about nuclear fission. So it's first telling about nuclear fusion, that is when atoms are joined together, and in fission the atoms are split apart. Obviously, we know what the meaning of those words are, right? Then it says, however, nuclear plants do not have the capability to produce energy from nuclear fusion safely and reliably. Okay, because it generates a huge amount of energy in a very short span of time, and sometimes it cannot be controlled and it might go out of hand very easily. So, nuclear reactors use these pellets of the element uranium as fuel to produce nuclear fission. Okay, so they actually carry out the process of fission over fusion. Okay, then it says that the nuclear reactor forces the atoms of uranium to break apart, that is, undergo fission. What is the nuclear reactor? That is the setup that I told you, in which, in a controlled way, the process of fission is happening to generate an electricity and energy in a controlled way so that it does not cause anyone harm. So, these uranium particles or nucleus are forced to break apart, and as they split, the atoms release tiny particles called fission products. We also know what that is. These small particles, they break apart, the nucleus breaks apart and gives rise to fission products. Then fission products cause other uranium atoms to split, starting a chain reaction. So if that wasn't clear to you, what I told you when I just said that it is done in a chain reaction in a controlled way, this is the representation of it. This is the visual representation. So what is happening? One uranium atom or nucleus breaks apart into its products. Those products go and hit the other uranium atoms, then they break apart, and this process keeps on going like a chain. This breaks apart, hits this breaks apart, hits this. So this keeps on going and energy is generated, but in a controlled way. Okay. So it says the energy released from this chain reaction creates heat. Okay, great. The heat created by nuclear fission warms a cooling agent, usually water. So water is usually heated. So what happens when water is heated? Steam is produced. That steam turns the turbines, and that turbine generator or the turbine rotating is creating electricity. Right? So that is the process that we have seen everywhere, be it thermal power plants, be it solar thermal plants, be it hydroelectric plants. It is always a turbine rotating and generating electricity. Okay. Then it says that nuclear energy can provide clean, pollution-free power with no greenhouse gas emission. Okay, so because there is no direct smoke or any other greenhouse gases released in this process, you might think, okay, this is like one of the best methods for electricity generation, but we are also going to see its cons in a bit. Okay. However, nuclear reactors do produce radioactive waste like uranium pellets. This waste can be extremely toxic and stays radioactive for thousands of years. The government regulates how these materials are disposed as of to avoid radioactive contamination. So, what does this mean? The byproduct, which is those uranium pellets, it is very difficult to dispose them in a safe way. Say you just dig up the ground and you put them there. That uranium can actually seep into the groundwater and contaminate the underwater table or the groundwater, and then it would actually come into all of our houses, and then we would be affected and we would get deadly diseases. Or if it's just thrown away normally in the dumping ground, it would keep releasing its radiations and it would affect all of the people around it and their generations to come. So a lot of these diseases that are caused due to radiation, they just don't stop with one person. They are usually passed down from generation to generation. So many other generations to come after you would also have some or the other side effect of that radiation that you experienced. Okay. So that is why it is not used at a very large scale. That is why it is controlled by the government, and that is why it is trying to be used at a minimal scale. But because again it is pollution free, definitely, and it is a very high source of energy, that is why it is actually being considered as a source in the first place, even though it has these cons. Okay, great. So as you just saw in the video also, we are again going to see some of the hazards of nuclear power generation. Storage and disposal. So what does storage mean? Before it is even used, to be even stored in one place, it is very difficult, because the main reason for it is the release of the radiations. And disposal, what does that mean? It means once it has already been consumed, whatever is the leftover or whatever is the byproduct, that even being disposed or being discarded or being thrown away is extremely difficult, because it releases all these radiations that could affect people. Disposal of spent or used fuel. Improper nuclear waste storage and disposal result in environmental contamination. Okay, the risk of accidental leakage of nuclear radiation. This is what I was talking about, the radiation. That is the most dangerous side effect, and that is the most dangerous part of using nuclear energy as a source of energy or for generation of electricity, because the radiation is very, very dangerous for anyone that comes into contact with it or is exposed to it, right? The high cost of installation, again, these are all cons of it, you should remember. Okay, storage and disposal, very difficult. Okay, then environmental contamination. Since these are radioactive elements, so what happens because of that? Radiation hazard. That means that radiation, if we are exposed to it, we can get many, many diseases which will be passed on many, many generations. Then high cost, very high cost of setting up those reactors, nuclear reactors in which the chain reaction takes place. It is extremely high costed, high cost of installation or setup. Again, these are the same points being repeated. High risk of environmental contamination, limited availability of uranium. This is your next con. Limited availability of uranium makes large scale use of nuclear energy prohibitive. It's not even saying like dangerous or not, not a good idea. It is straight away saying prohibitive. That is why governments absolutely ban the use of nuclear energy, because they say that the people are more important to us than the generation of this electricity. There is too much at risk when we are using nuclear energy. Okay, great. Now we're going to study about the other process of nucleus, which is nuclear fusion. So as the word suggests, fusion is the combination of two or more nuclei to form one parent nuclei. So this means that the fusion means joining lighter nuclei. What was happening in fission? Heavier nuclei breaking apart into lighter nuclei. In fusion, many light nuclei join to make a heavy nucleus. Just one nucleus forms. Okay. Usually hydrogen or hydrogen isotopes create helium, and this is the chemical reaction for it. Okay. Plus N means neutron is released in this process. So you can see here deuterium, tritium. These are all isotopes of hydrogen. I'm sure you studied about it. They all combine to form helium and one neutron and energy. So, deuterium, tritium, these are the reactants. These are the reactants, deuterium and tritium. And products, what are the products formed? Using deuterium, tritium, helium is the product. Energy is the main product that we actually need here. This is what we are going to work with, the energy and one neutron. Okay, this is the process of fusion. Great. Now, the conditions needed for this process are extreme, millions of degrees of temperature and millions of pascals of pressure. So, do you think it is possible to actually perform nuclear fusion in a normal laboratory? It is absolutely not. Millions of degrees of temperature and millions of pascals of pressure. That is a very, very, very high level laboratory only can produce that kind of, physical situation or physical environment. So that is again something that makes it very difficult to generate on a large scale. The hydrogen bomb is based on a thermonuclear fusion reaction. Okay, it actually is a mixture of fusion and fission reaction. Okay. You have this small box in your NCERT that explains it very nicely. So you can just give it a read. Again, that is just for your information. You may or may not be asked about it, but you should know about it. Okay. It is a very good thing for your GK also. Okay. Now, what kind of mirror? So the first question here is, what kind of mirror, concave, convex or plane, would be best suited in a solar cooker and why? If you remember when we were studying solar cooker, there was this line that a mirror is used to converge the sun's rays. So why, first question you should ask is, why is the converging important? Obviously, if we want just that cooker to have all the heat, we've done everything to make it as heated as possible. So if this is the cooker, this is your cooker, right? This is the actual cooker. So what is the first thing we've done? We've made it black, right? Black absorbs more heat. What is the second thing we've done? We have covered the top of it or the opening of the box with a glass plate. So what does that do? Again, it traps the heat. It lets heat enter but not leave. And what is the third thing? The third thing is the mirror that is used here, right here. What is the third thing? The third thing is the mirror that is used on the lid. So just think about it at like a cube with an open top. So inside the cube there is the cooker. The cube is covered with a glass plate and the top is hanging up like this, and on the top is the mirror. So the third thing is the mirror. So we know black absorbs heat, right? Glass plates traps heat, and this mirror is for converging the lights. So now think about it. Which of these mirrors is used for converging light rays? Convex mirror, diverging mirror, plane mirror does not converge or diverge. It's a normal mirror. Concave mirror, it is a converging mirror. You remember, this is a concave mirror. You should remember all of these points now because you have studied it. So you are expected to know it. If this is the focus, the light rays go like this. So they are converged at the focus. So if a suitable mirror is chosen so that the cooker is at the focus of the mirror, what will happen? All the rays coming from the sun would be converged into the cooker. So it would get heated up to a very high degree and the food will be cooked quickly. Okay, great. Moving on. Second question says, what are the limitations of the energy that can be obtained from the oceans? Okay. So let's think about it. Let's break it down. If we think about the two types, you remember the two types of energy from the ocean were tidal and from the waves. So if we think about the limitations of tidal first, and then we'll think about the limitations of waves, and we'll see that they're almost the same. So you'll write the line first. The limitations are as follows. So if we think about the first one, it would obviously be the high cost, right? Because it has to be a big dam-like structure with the sluice gates, with the turbine, set up in a very, expensive place also. So high cost definitely for both of these things. Okay. Then if we think about it, we learned that the construction of dams affects people. So think about it. Wouldn't the construction of tidal, the setups for tidal and waves energy generation, wouldn't it affect the marine life forms? Wouldn't it affect the fish living there? Yes, definitely. So effect on marine life, negative effect, right? I'm writing in bracket negative. So you should write negative effect on marine life due to the building of these dams. Then if we think about the waves, would the waves be equally forceful every single day all throughout the day? Or would it be like super forceful some day and it would have absolutely no force on some days? Right? It is not going to be consistent. It's nature. Nature can't be absolutely on point every single time. It's completely dependent on itself. There is no constant. It's completely variable. So, variable nature of waves. So it cannot ensure us that every day you will generate the same amount of electricity. So you can't give anyone this target. Yeah, today we are going to generate this amount of electricity, because if the waves are in full of force that day, you would not get any electricity. So that is why it can't be absolutely fixed. So that is another con. Okay. Then we know that the tides are generated due to the moon, the gravitational pull of the moon. So it is actually dependent on moon. So it is not in our hands. We don't know when it's going to be high tide or low tide. We don't know how much energy we are going to generate, even if it's high tide or low tide. So again, it is very variable. We do not know how much we're going to be able to generate. So that's another con. Then one thing we forgot was variable. We do not know how much we're going to be able to generate. So that's another con. Then one thing we forgot was thermal, the ocean thermal energy, right? When we learned, right, when it is like a difference of 20 degrees Celsius between the surface and the lower layers or the deeper layers of the ocean, right? So another disadvantage is that 20 degrees Celsius difference, Celsius or Kelvin, it's the same, is must to generate, to not to generate, to harness ocean thermal energy. Again, another limitation, we can't just do it anywhere at any distance from the surface at any temperature difference. It has to be 20 degrees Celsius, and it has to be 2 kilometers from the surface, around that much, right? So all of these things you have to keep in mind. That is why we can't always completely rely on the oceans or the energy obtained from the oceans. Okay, let's move on to the next question. So it says, what is geothermal energy? Okay, so we learnt about geo means the earth and thermal means heat, right? So we knew that geothermal means that the heat of the earth. Okay, great. So what is the process? I'm not going to write it completely. I'm going to explain it and you are going to write it in your own words. So we learned that, I'm writing it in short form. Okay, we learned that the molten rocks below the surface of the earth, much deeper, sometimes are pushed up. Okay, so when they come in contact with what? Groundwater or the water underground, what happens? Steam is generated. I am writing it in very short and in these symbolical forms. You have to write it complete sentences and in your own words. Okay, so what happens? Steam is formed. So it forms steam, right? This steam finds an outlet, and the steam and water, hot water, finds an outlet and it forms hot water springs, right? What are these called? These molten rocks are basically known as, they pushed up and they are known as hot spots, right? Okay, so this is, and then you'll write one final line. When the energy of this steam and this hot water, when it is trapped and it is used for generation of electricity, that energy is known as geothermal energy. Okay, great. Now, what are the advantages of using nuclear energy? So we learned that it is pollution free, right? It does not no greenhouse gases, right? Then what does it happen? Millions of times the energy generated by carbon and other fuels, millions of times the energy generated by other fuels, right? And right now we don't know a proper way of disposing it, but maybe in the future sometime we will. So it also has a future prospect, or it also may have a lot of actual future in later times or coming times. So in the next video, we're going to learn about the impact that these fuels can have on the environment and the depletion of the various sources of energy, and also we'll do a quick revision of the chapters. Okay.